Hello everyone. In last lecture we have discussed few non-destructive testings: visual check, paraffin and whitewash test, magnetic particle test and hydraulic test. Now let's see another test. The next test is stereoscopic test. In this test, the weld is observed by striking the hammer on the weld. You can see one hammer is indicated over here and one stereoscope is here. So what is basically done in this test? The weld is observed by striking the hammer on the weld and hearing the sound which is produced by striking the hammer. If weld is defect free, then metallic ringing sound will be there, and if there is any kind of defect in the weld, then there will be a dull sound. And it can be compared with a defect free bell because the bell gives sharp and high intensity sound when there is no defect in it. This test is usually check pressure vessel and structural welds. This is a simple kind of test. Now next is air pressure test. Air pressure test is similar to the hydraulic test which we have seen earlier. In this test, for increasing the pressure inside the vessel, air is used. So it is easy to test pressure vessel by this method. One pressure gauge is used to know the pressure inside the vessel. Soap water is applied on the weld area which is to be tested. When the vessel is under pressure, airflow will cause bubbles to form at the place of defect from where leaking is identified. So wherever the weld is done on pressure vessel, if there is any kind of void or crack or any other vacant space, the soap water is applied, and if any crack is present over there, then due to the air pressure, the soap water will be converted into a bubble form. So this particular test is basically done during the time of installation of gas pipelines which is installed in our home. So this is a simple kind of test. Now next is a radiographic test. Radiography is an imaging technique using X-rays to view the internal structure of an object. For radiographic, X-ray generator is used and is projected towards the object. The radiation used in radiography is a higher energy version of the electromagnetic waves. It is nothing but the part of electromagnetic waves. The radiation can come from an X-ray generator or a radioactive source. So let's see how it comes from a radiation source and how it is projected on this particular film. When rays are thrown on the component from X-ray source, then they absorb equally in whole area, and the image formed on film gives same intensity. But when there is any defect in component, unusual absorption of ray giving the change in intensity. So if in this particular part, if there is a void or crack is there, then the rays which is coming from a radiation source will be observed over here, and the intensity of that particular area will be different from the adjacent material. So the part is placed, you can see part is placed between radiation source and a piece of film. Radiation source is here and film is over here, right? The part will stop some of the radiation because part is a solid form, so it will absorb some radiations. Thicker and more dense area will stop more of the radiation. The more thicker the path is, the more radiation will be absorbed. So you can see over here less exposure is mentioned here and more exposure is mentioned here. So if crack is there, then there will be a less exposure, right? Because radiations are not absorbed here as compared to the adjacent part. So it is simple kind of thing, but we cannot find out how much deeper it is. So let's go through its advantages and disadvantages. First point, it detects both surface and subsurface defects. It detects, but it doesn't says it detects both surface and subsurface defects, but subsurface defects are not clarified how much deeper it is. Point number 2, it provides a permanent record of the inspection because it is recorded on this particular film. So it will be a permanent record. It can inspect assembled components. And last point, it has a very few material limitations. Now next, disadvantages. Its equipment is costly. X-ray is injurious to the health of the operator because it is having a high intensity light. Then high degree of skill and experience is required for this radiographic test. And last is depth of discontinuity is not indicated. As I have discussed over here on the first point of advantages, subsurface defects, how deeper it is we cannot clarify. Okay. Now next is ultrasonic test. Ultrasonic test is based on the pulse echo method. Acoustic waves are generated by ultrasonic machine. So this ultrasonic waves is the waves with having frequencies from 20 kilohertz to 20 megahertz, which are induced pulse-like into the workpiece to be tested by a probe. The pulse duration is usually a few microseconds. These sound pulses propagate in the workpiece. These sound pulses will go into the workpiece with characteristic sound velocity. So let's go through this particular figure. You can see one object is here, one probe is here, which is used to check the defects. One CRO is there, cathode ray oscilloscope, on which we will see how much amount of crack is there. That means according to the distance covered by this particular ray, by this particular wave, we can come to know how much deeper the crack is. So you can see when no foreign material or no inclusion or no any defect is there, the wave is coming from the transducer and it is going back again to the transducer in a particular waveform, right? So when any defect comes in the path of the pulse wave, if any defect comes in the path of this pulse wave, these waves get reflected from that particular point. So this is indicated over here in crack. You can see crack echo is there. So whenever any defect comes in the path of that waves gets reflected back. It doesn't cover the whole distance of the object. It will go from this particular defect. So it can be viewed in CRO of the equipment. You can see over here, when there is nothing inside this object, the waves was not changing. When there is a defect, this wave is changed over here. You can see the flow echo. From the CRO, cathode ray oscilloscope, you can easily identify how deeper it is. Okay. Now, advantages and disadvantages. It is fast and reliable. It is more sensitive, hence very fine defects can be found. This method is effective even for large size components. Disadvantages. Surface to be tested should be smooth and clean because this probe is kept on the surface of the job. So its surface should be cleaned enough. Then skilled workers are required to note down the digital readings. Then third point is non-applicable to complex shape and design, right? So if a part is having a complex shape, then it is not useful. The next is eddy current testing. Now this method is applicable to electrically conductive materials only because its name says eddy current testing. So current can pass in only conductive materials. So in this method, eddy currents are produced in the product by bringing it close to an alternating current carrying coil. So what is eddy current? Electric currents are generated in a conductive material by an induced alternating magnetic field. The electric currents which are generated due to this thing is called as eddy currents. In this test, a generator is used, a coil and recording equipment, that means a galvanometer or an oscilloscope is used. So you can see over here, one coil is there. When an alternating current passes through a coil, a primary magnetic field will be generated around that particular coil. The alternating current primary field induces circular eddy current in the object which is held below the coil. So this secondary magnetic field arises due to the eddy current. As I was saying earlier, electric currents are generated in a conductive material. Electric currents are generated in a conductive material by an induced alternating magnetic field. The electric currents are called eddy current. Okay, so whenever we will pass the current to this particular coil, it will induce some current. So in order to generate eddy currents in an inspection, a probe is used. A probe is having a primary coil. So eddy currents flowing in the material will generate their own secondary magnetic field. That means the eddy current which is generated on the object, it will produce its own secondary magnetic field, which opposes the coil's primary magnetic field. So if crack is present on the object, it causes a disruption in the circular flow pattern of the eddy current and it will weaken their strength. This change in strength at the crack location helps to detect, because the impedance which is produced due to this primary magnetic field, the impedance which is produced over here due to the primary magnetic field, it will be in a circular form. But if there is any crack, then there will be irregularities of this magnetic field. So the impedance is changed. Due to that, this primary coil's magnetic field will be changed. So that thing will be noted over here on galvanometer, on oscilloscope. You can see, just see this object and see this pointer. In our concept, we are moving this probe, we are moving this coil around the job, but in this thing, job is coming into this particular coil. When job is coming inside the area of this coil, it will get changed because crack is there. If crack wasn't present, then this current meter will not be changing. Now advantages and disadvantages. It is high inspection speeds. Now advantages and disadvantages. It is having high inspection speeds. It can detect flows through paint layers. It doesn't mean we have to go through only non-painted products. We can also check painted products. Test probe does not need to be in a contact with the part. That means the contact is not necessary. Disadvantages. Only conductive materials can be inspected because eddy current is required to be produced. So only conductive materials can be inspected. Skill and training required. Surface finish and roughness may interfere, because if surface is not smooth, there will be a change in current due to the change in magnetic field. Now next is dye penetrant test. This is one of the most important and mostly used test in industry, dye penetrant test, which is basically used for checking surface cracks. So what is done in this particular test? You can see liquid penetrant is applied to the surface of the component and is permitted to remain there for sufficient time to allow the liquid to penetrate into any defects. After the penetrant time, the excess penetrant which remain on the surface is removed. Then a developer is applied to the surface. This developer draws out a portion of the penetrant which had previously seeped into the surface openings. So what do we have to do? First we have to apply a penetrant which is of red color maybe. Thereafter we have to let that penetrant over there for seeping into the crack. So after seeping into the crack, the upper portion of the object, upper portion of the workpiece is cleaned by water. Thereafter, a developer is applied to the surface. This developer draws out a portion of the penetrant which had previously seeped up or soaked up into the surface openings. As the penetrant is drawn out, it diffuses into the coating of the developer, which will show the defect. So you can see how dye penetrant test is done. First, we have to clean the test piece. Thereafter, penetrant will be used. Apply penetrant all over the workpiece. Then it will go into this crack. If crack is present, we have to allow it to soak or seep. Then rinse the test piece, or rinse off the penetrant from the top surface of the object. Then developer will be used, which is of powder form or liquid form, which is having white color. After applying developer, we have to wait. So the developer will soaked up or seeped up this particular penetrant. So this thing will indicate us that something is present over here, just like a crack, right? So this was the thing with the dye penetrant test. Let's see its advantages and disadvantages. This method is simple. More skill is not required. It can be used for metals and non-metals. Then disadvantages. It cannot be used for porous component. And next is internal defects cannot be found. As I have told you earlier, in this test only surface defects are detected. We cannot go through the internal defects. So in this lecture we have covered all the rest of the test: stereoscopic test, air pressure test, radiography test, ultrasonic test, eddy current test, and dye penetrant test. Stereoscopic test, in which hammer was used for striking the object. By striking the object and hearing the sound, we can come to know if there is any crack or a defect. If there is a dull sound, then there is a defect. Then air pressure test. It was similar to hydraulic test, but in this test air was used for increasing the pressure. Then radiography test, in which X-ray was used to find the cracks or any other defects. But in this test we cannot know how deeper our defect is. The next was ultrasonic test, in which pulse waves were used to find the crack. So in object, any defect is there at any level. By pulse waves we can easily find out how deeper our defect is. The next was eddy current test, in which one coil was used. That coil will produce a magnetic field, and due to that magnetic field in the part, eddy current was there. Eddy current were in circular form. So if there is any crack or any irregularity on the surface of the job, that eddy current's impedance will cause an effect to the primary coil's magnetic field. So this change will be indicating us how defect is. And last one was dye penetrant test. In dye penetrant test, first we have to clean the surface of the job. Thereafter we have to apply the penetrant, then let it be over there for seeping up into the crack. Thereafter we have to rinse it off from the surface of the job. Thereafter we have to apply a developer on that particular surface. So the developer will soak up the previously placed penetrant. So if developer is showing a red color, we will come to know there is a crack on the surface. So in this lecture we have covered all these non-destructive tests. Thank you.